and then the section objectives are right here. So first thing, you could just throw this out because it has nothing to do with the actual course. So we started here. So I just copied this and pasted it into my document. I actually took a screenshot so it would look nice, but maybe you'll type it out. However you want to do it. I took this and I put it here. So okay, I've got this here. This is in section 1.1 what I need to be working on understanding. Right? I need to have the vocab and symbols down pat. By the time you're watching this is probably week 4 into week 5. We've got to have these down. This is the foundation of the course. If you don't have these drilled in, you're going to have a bad time. So that has to be part of your focus. So let's just start there, right? How can we get these into our head? What's the best way to kind of try to do this? So let's first just start with the symbols. So let's take the symbols here and talk a little bit about them. So first things first, you should just write down the symbols, and then each time you write one down, tell me what it is. Well, pi is a parameter, first off. If I see pi, I should think parameter, and specifically, not only a parameter, but it connects with a proportion. It's always going to be the proportion of something. Proportion. Oops. So it's a parameter and it's got to be a proportion of something. So don't forget, you can always think of that as I should be able to express pi as a percentage of something. That's it. That's as far as you can go for pi right now. One thing you could do extra is put an example for yourself. So over here we've got like a what is it, right? So what is it? And over here we have an example, right? So you can do a little example for yourself. So this, you just go grab any example that you've read through, we've done in class, in the homework that you really liked, or make one up for your own, right? So in the homework, we liked bears. Maybe we like bears. So pi was equal to the proportion of female bears in the park. So this was from written homework 1, right? And then you got to think about it. Like, okay, well, what makes this pi and not something else, like p hat, right? Well, remember, first off, proportion, that's the word we're looking for. And then remember, the pi is a proportion about the entire population, the big group, right? And so remember, for that homework problem, the population was all the bears in the park that we were interested in. So just, to remind us what this is, again, in our own words, it will be a proportion. So it's going to be a proportion every time of something. The something depends on the problem, right? So the proportion of female bears, the proportion of heads. There's lots of options, like different things that could happen. But specifically, this is about the population. That's one of the key points here to help you out when you're doing this. It's about the population. So, okay, what's next? P hat. Well, these go together. So p hat's next. This is a statistic, but it's also a proportion. If you write down p hat, you should be thinking proportion, percentage. Okay? If you want to keep going with the same example, you can, or you can put up another example for yourself. So in the bear example, p hat was, if I remember correctly, 13 out of 29. Right? So this was the proportion of female bears. Looks like I'm writing the same thing, right? In the sample. So not in the whole park, just in the 29 bear sample we collected. So what's the key point here? What's one of the key points? It is a proportion of something again. So again, this is a proportion of something. But again, this is not about the population, it's about the sample. So we've got to be thinking that over. So we'll give ourselves some space here. we've got pi, we've got an example, we've got some important things about it. We've got p hat, we've got an example, we've got some important things about it. Keep going. What's the next one? Mu is next. So let's give ourselves a little space here. We've got mu. What is this? Again, it's a parameter, right? So it's a parameter. More specifically, though, it's going to be a mean. And sometimes we'll use the word average. So if you write down mu, you should be talking about a mean or an average. All right? Example. We might be interested in mu is the average height of adult males in the US. Talked a little bit about this. This is an example you could use. Okay. Again, though, look, I'm talking average. That's important. Look, there's a little average here. That's good. You got to have that. And then I'm talking about the big group, the population. So a little note you could make. It is the average something. So again, this is fill in the blank. Height, age, income, whatever. There's like a little fill in the blank here that you got to fill in. This like little something box. Okay? So you got to fill that in based on the problem. But again, just to note, this is about the population. If it's mu, it's the population. Okay, what's next? Well, x bar was next. What's x bar? It's a statistic. But this time it's not a proportion or percent. It's a mean or an average. Okay. Example, again, you can connect it to the one you just did. You can make up a whole new example. This could be the average height of, and then how do you learn about all US males? You got to take a sample. So a sample of adult US males. Again, what's the kind of key point here? This is an average something, in this case height, but depending on the problem, this changes. Okay, but what's the key point? This is about a sample. All right. Last but not least of these symbols that we have here is n. This is the sample size. All right, and pretty much everyone's been doing a really good job on this. Sample size, it's just the number of observational units is the way you can think about it. It's the number, if you're dealing with people, it's the number of people you asked a question. It's the number of coin flips you did. It's the number of bears in the woods that you saw. There's not too much more to say here, but you can do an example for yourself if you want to. So in the example above with the bears, n was 29 because our sample was 29 bears. All right, so good. Make examples for yourself. Okay, so we've got the symbols down. Now it's for the actual key terms. So you go back up here. You got your key terms here. So you also see I have the book open. And the book for each of these key terms has a definition. But when you're trying to make up a study guide for yourself, this is already something you've looked at. You've already done examples. You've already gone through this. And so you can just rewrite all of this if you want to, and that's fine. But a better way to do this would be to try to now take each of these and put them in your own words. Try to draw your own pictures, give your own examples, or just bring in other examples. So we don't necessarily need to have these perfect. What we want to be able to do is make each of these our own now. So, for example, let's just start with population. So here we go, population. So what is this? So population, we could go down here, the entire collections of persons, things, or objects under study. But you might want to instead say something like, for me, the way I think about it, instead of that definition, is the big group of things I want to learn about. Right, so that's slightly different than this population definition, but in my head, this reminds me of the important things. It's the big, right? So this says it as well, the entire collection. It's just a fancier way of saying it's the big one I want to learn about. And so again, though, for myself, I'll put down a couple examples. Example, I might want to learn about all DCC students. That could be something I want to learn about, right? And this would be people, which is a common example. But there's others, right? I could want to learn about all flips of my coin. I'm interested in if my coin is fair or not. So I'm interested to know, like, okay, what would happen if I flipped it and flipped it and flipped it forever and ever and ever? And if I could learn about that, I can learn about my coin. Right? So a couple examples for yourself. And if you're going to give more than one, try to make it a little different. All right, what about sample? So then we could do the sample, right? Same thing. Let's read it on here. To study the population, we select a sample, which is a portion or subset of the larger population. Okay. So what is the sample? So the sample is the small group we actually study, or another way to think about it is collect data from. All right, so that's just my own words. You should try it in your own words too. But it's the smaller group that we actually study and collect data from. And to try to nail home kind of the connection between these, you draw yourself a little picture. Here is your population. Right, here's my population. And then, well, what's the sample? The sample's smaller, so we should draw a smaller circle. But the other key point is the sample is a part of your population. Here's my sample. So the sample is a smaller part of the population, but it is made up of the population. So if I'm looking at all DCC students as my population, then when I take a sample, it should still be DCC students. It's just not all of them. It's just the ones that I'm going to actually talk to. If I want to learn about all flips of my coin that could ever happen, my sample, it should be flips of a coin, but it's not going to be all of them. It's just going to be the ones I'm doing. Right? So add pictures in, add examples, things like that. So then you can continue examples from the ones you've previously done, or you can make up new ones on, or add in new ones that are different. So for above, I could say something like, instead of all DCC students, my example could be 30 DCC students I survey. It's the smaller group. Okay, and then you just kind of keep going through here. So we've got other terms: parameter, statistic, variables, and you could just keep going through here. So we'll do it together for this section. We'll just keep kind of going through here. So next up, we could do observational units. What are the observational units? All right, well, again, let's just kind of scroll up here and see what it says. It says the individual entities on which data are recorded. Okay, so the individual entities on which data are recorded. So we got to think of a way to say that maybe in our own words. So first things first, we should be thinking about this definition, because I keep underlining things and pointing out this for observational units. The individual. So observational units, we want to think as single individual things. Okay? So little things. And these are the things we directly gather data from. All right? So the observational units So each observational unit is the individual, the single thing you look at to collect data. All right, so maybe you don't like the word individual entities, so we could say something, maybe we could just change it up, ready? The single, so what does this imply? One at a time. The single things we get data from. So it's the one thing at a time we grab and we get the data from. So for example, if you want to keep going with the previous examples, right? So give yourself some example. Okay. So I took a collection of 30 DCC students and I surveyed them, right? So my observational units will be a DCC student. That is a single one. See, I'm being very deliberate with this. The observational unit, that's the single DCC student. I grab a DCC student and I say, survey, answer this question. My other example, a single coin flip. That's my observational unit because I gather data from that one coin flip. Previously, right, we were doing rock, paper, scissors. A single throw of rock, paper, scissors. Each individual one. A prison from the homework. A single prison. This is I'm stressing this because when we get to variables, it's important we get this. We understand that piece, right? Okay. So observational units, they're the individual, single, one thing that you gather data from at one time. So your sample has many of them in it. So like the 30 DCC students, that has many observational units, 30 of them. But when we want to talk about that, we need to focus down. What's the one thing I look at a time? I look at one student at a time, one coin flip, one throw of rock, paper, scissors, one prison. So that kind of goes nicely into variable. So what's a variable then? Right? So let's read it. The variables, the recorded characteristics of the observational units. Like that's a definition, right? That's a math definition. So again, let's put this in our own words. The recorded characteristics, that's the key word here, characteristics of the observational unit. So it's connected to observational unit. So put an example in your head. Start with an example. A DCC student. Now tell me what is, in general, what's a variable? A variable about a DCC student. So the word characteristic is a good word for this, right? But, you know, even at this point, we'll just stop here because this is such a good thing to do. Watch this. So I'm sitting here with this definition, and I'm thinking to myself, like, what in the world's going on here? And so here's what I'm going to do. I'm going to go to Google. Okay. Let me bring this up. So I go to Google. Okay. So characteristic. If you get a word like this and you're not sure, go find synonyms, right? Let's look at a characteristic. Typical of a particular person, place, or thing. Okay. A feature or quality belonging to a person, place, or thing. Okay. So here you go. Attribute, feature, quality, property, trait. All of these are different things we could use instead of the word characteristic. So what you have to do when you run across something like this is you try to go find to see if there's another word that can help you here with this. So an attribute, a feature, a quality, okay, that belongs to that thing or about it. So what could we say here instead? Instead of a recorded characteristic, right? Recorded still a good word. So we'll say a recorded because it's important that we remember this is something I'm going to record about each student, coin flip, prison, whatever. So a recorded, and then you just pick whichever word fit the best. So let's go back to it because I already forgot them all, right? That's not good. So go back here. attribute, feature, quality, property. All of those are good things that you can do. You can think about. I like the word feature. So a recorded feature, which I like that, of each observational unit. And I underline each because, again, when you're thinking variable, you need to stop and say, okay, I just wrote down this variable. Is this something I can record from each observational unit? So this happened for some people on the homework. The observational units, that was prisons. So an observational unit is one single prison. So when you go do a variable, you are asking a question. You are looking for a feature, a characteristic, whatever word you like better there, about one prison. So your variable, I have to be able to go to a prison with my variable in hand and be able to say, okay, you prison, I can record something about you for this variable. So example. And it's interesting. You have to have the observational units here for the variables to like really make sense of them. So I'll start with the observational unit here. And let's make this a DCC student. Okay, so then you can do the variables. So what are some variables we could do here? What could I ask about each DCC student? Height, age. What else could we ask about them? Political affiliation? Do you have a car? Do you have a job? Right? What's your favorite ice cream? Or maybe a side question to that, are you lactose intolerant? Yikes. So all of those are things that are features, characteristics, insert whatever word you like, about an observational unit. So pick out an observational unit that you're comfortable with and then just list off things you know about a single one of those, not the whole collection. Notice I did not write anywhere students because that's not my single observational unit. I wrote student because I want to focus on one at a time. So when you're talking variable, when you're talking observational unit, you need to zoom in and focus on one at a time, one of them. What can you get from one of them? We talk about the collection, but that doesn't come until statistic. That doesn't come about until parameter. So they're separate things. And then this leads us nicely into categorical and quantitative. So categorical, right? Categorical, variables whose outcomes are a set of categories. Sounds kind of like circular, right? So maybe that's not a great one we want to hold on to. So what do we want to say instead, right? So an important thing is outcomes, right? The options. So if you don't like the word outcomes, look up something different. The options that you have for your variable, of the variable. So instead of categories, if you don't like that word, it's a fine word, right? But you can try something different, right? The outcomes of the variable, you can write are categories, or you could try to think of something different, like, or you could explain it differently. Outcomes or options of the variable that put the observational unit into a box. Maybe this is completely unhelpful. You don't like thinking about it, and you like this. That's fine. But what you want to think is, if this is a categorical variable, right, then that means that the options that you have are boxes you can put into. Here's a box, chocolate ice cream. Here's a box, vanilla ice cream. Here's a box, strawberry ice cream. Here's a box, heads. Here's a box, tails. Right? So each observational unit, right, goes into one of these boxes. You grab the observational unit, You get the data, and if the data ends up taking your units and putting them into these boxes, these separate boxes, then it's categorical. This is my way of thinking of it. You have to think of your own way. I guess you could take my way, but you want to think of your own way as well and write this out. Quantitative. Okay, so quantitative. So this is different. The outcomes are in general numbers. And we added this a little bit later, can be averaged. So we want numbers that can be averaged. So get yourself some examples. Height was one. We can look at the average height. And then what you want to do, maybe like a little note for yourself, is complete this sentence. The average, and then put in the variable. Right? So if you're looking at a quantitative, if you're looking at a variable and you're like, ooh, I get numbers when I look at the data, then if you're like, ooh, but I'm not sure, ask yourself this question or say this out loud. The average blank, put in your variable name. The average height, the average age, the average zip code. Wait, what? The average zip code? That doesn't make any sense. So then you're thinking, that's not quantitative, that's categorical. That puts me in boxes. Because zip codes are areas, and you are in one area. You're in a box. So that's one way you can kind of help yourself. The average blank. Ask yourself to, or say that out loud and see if it sounds right. All right, and then the last thing we have are the parameters and statistics. So let's go down here. Parameter. All right, parameter. So what's the parameter? Well, let's just read this and see what we think about it. A numerical value that states something about the entire population. It is generally unknown because we generally can't gather information from every single element of the population. We want to understand this. So go back to the top. A numerical value that states something about the population. Okay? So what can we get out of this? You can pare it down. Put it in your own words. A numerical value. A number. We don't need to be fancy. It's going to be a number. We don't know it generally, so you might want to make a comment about that. We'll make it at the end. But it's a number, okay? And then that states something about the population. I mean, that's fine. If you like that, that's fine. You can write that. But you could put it in your own words, like a number that tells me something about the population. Just my own way of saying it. And we're going to add to this because I've said this a few times. So note one here is that the parameter usually measures. We have to be a little careful with that word, but I think the idea of that word works. Usually measures something to help answer a research question. So remember, there's still that sitting in the background. We still have a research question usually that we're trying to answer. And once you set up the research question, the parameter is your way of getting a number, again, a number, that will help you answer the question. DCC students, I want to know about how much DCC students are working. So example, and I'll give you a full example with the research question, right? Do DCC students work more than the average college student? Maybe we could do community college student. Whatever your question you might be interested in. Okay, so that's my research question. I'm thinking DCC students, are they working more, less, what's going on here, than the average college student? Well, how would I answer this question? I would need to know about the DCC students. So first things first, my parameter needs to be about DCC students. Okay, so that's first things first. And then it has to be a number that would help me answer this question. And so what could that be? It could be mu. I see the word average. Mu is the average number of hours a DCC student works. There you go. So, okay. Now you've written that down. First things first, you saw the word average, so you wrote mu. Check that. Second thing, think to yourself, pretend I can find this number. Okay, so let's hold on to that. I found this number. Then go back to your research question, which we'll put like a little question mark here. Whoa, that is not a question mark. There we go. Question mark here. Does it help you answer that question? If you knew the average number of hours a DCC student worked, would you have information that helps you answer that question? Yes. So that's probably a pretty good parameter. Now, do you need more information to answer the question? Maybe. But the parameter doesn't have to be the end-all of solving a question for you. It just has to be something that gets you closer to it. All right? Just to add in here, right, we could think of other parameters that would help us with this question. Pi, right? When I say students work more, one way to try to measure if DCC students are working more is to look at the average hours they work, of course. But, I might also want to know not just the average hours you work, but I might also be interested in what percentage of DCC students are working? That seems like a valuable thing to know. The proportion of DCC students who work. That's another parameter. It's a proportion, so I wrote pi. It's about DCC students. It's a number about them, right? So parameter. And that would help me answer this question. So sometimes you're going to have a couple different ways you could do parameters that help you learn about your question. That's okay. Totally fine. So we got parameter. All right. What's next? Statistic. So let me give some room here. Statistic. Okay, well, let's read it, see what it says. So statistic, a numerical value, a number, a numerical value. We're so fancy. It's a number. A numerical value that states something about an observed sample. So there's no change here, except the only change here is that instead of being a number that tells me about the population up here, it's a number that tells me about the sample. That's it. Only change. Look how close these are. A number that tells me something about the population, P, right, goes with it. A number that tells me about the sample, S. Right? Use these little tricks to help you remember. All right, so connect it to the example that we just had up there if you want to, or make up another one. That's fine. X bar would be the average number of hours, right? This is the average number of hours a DCC student works from my sample. So only from the sample I talked about. So X bar just from the sample. Okay, and P hat works the same. P hat in this case, right? The proportion of DCC students from my sample who work. Important. Just about the sample. Again, look, you almost wrote the same exact thing. Average number of hours a DCC student works. Average number of hours a DCC student works, but just from my sample. small. The proportion of DCC students who work versus the proportion of DCC students from my sample who work, small. It's almost like the same exact thing, except for it's just who are you talking about, right? And remember, like this added little connection you can make, right? Added little connection is that you know the statistic. You don't usually know the parameter. And so our whole point of statistics is to take what we know and try to help us learn about the parameter. That's our goal. Our statistics is like a little snapshot of the big group that we're trying to learn about. And so we use that little snapshot to try to learn about the big parameter that we don't know about. All right, so last thing on here is probability. Last thing we have to think about is probability. Okay, and so what does this say? The long run proportion of times that the event occurs. This really is important. We really do need to understand that this is long run. You know, this is very, very important. Long run. The probability has to do with the pattern you see when you do something many, many times. So maybe that's what we could write here. If you want another way of thinking about the probability of something happening, right? The probability, you know, what is the probability of head flip? Well, that's going to be, it's a number, first of all. So we'll write that, a number that describes the long run, again, critically important, pattern. So the probability is a long run pattern. Okay, it's the long run proportion of times an event occurs. However you want to think about it, it's fine, but the key point's long run. So if I ask you what a probability of something means, you immediately need to go, well, if I do this thing many times, I expect da-da-da-da. That's what it should look like. You should not be just replacing the word probability with chance or luck or whatever. That doesn't make any sense. You don't do that when you know someone's trying to explain something to you. You don't just start saying synonyms, because if they don't know it, like the idea, then a synonym is not going to help them. So again, no synonyms here. Don't just replace it with chance. You've got to tell me what it means in the long run. So what does it mean? We flip a coin. You guys tell me, for flipping a coin, we have the probability of heads is 0.50 or 50%. What does this mean? Right? What does this mean? It means if I flip many times, so long run, I expect to get heads 50% of the time. So with many flips, I'm expecting that when I look at all of those flips and I go, okay, count all the heads divided by the total, because that's how we do probability, I'm going to get 50% or close to it. That's what probability means, right? So, important idea. Okay, so I know that was a lot, right? I know that idea was a lot, but that is one way you can go back through a section to try to, really figure out what's going on. Okay, so what did we do? We went through here. We said, okay, I'm going to get the symbols down. Give myself some examples, right? Then I'm going to take each key term, write it in my own words, give myself examples. Own words, examples. Own words, examples. And you go through exactly like that, right? So the key things here that you should be doing are throwing down examples for yourself, that you feel comfortable with, and making each of these your own. Connecting it to things you know. Connecting it to your life through examples that you think make sense. Putting things in your own words. Googling other words and synonyms to try to help you kind of write it in your own language. I mean, we're all using English, but still, we all have our own language. So you need to be working on that skill. Make it your own. Make it your own. If you can do that, then you'll have a lot better time. And so what you can do from this is you can just finish this. Keep going. Keep going with the rest of these sections. Go to section 1.2, right? Like we can find section 1.2. Here it is. And we've got some other key terms. So again, simulation. Artificially recreating a random process under a specific set of conditions. Woof. Write that in your own words. Go back to the simulations we've done. See if you can think through that. Write it in your own words. Put an example down, right, where we've done a simulation. Just tell me what it means. Tell yourself, right? I'm not looking at this. Tell yourself what it means. Distribution of sample statistics. What is this? Give yourself some examples, some pictures. Describe what it is, all right? Use what we've talked about in class. The mean, we know what the mean is. Talk about it. Normal distribution. Draw the picture. Tell me what you know about it. Even though this is 1.2, you might think like, oh yeah, I should talk about the 1.3 stuff when I'm writing this for myself. Do it. You don't have to like stay strict to what section you're in. All right? And so that's what you got to do. You got to go through here and you got to keep trying to put this stuff together. 1.3, these rules. All right? What is that telling me? 5% rule. What does that say? This unusual, right? Don't just write the word unusual when you write this down in your own words. Explain what that means. What does it mean? We're talking about our sample statistic, right? What we really did. What does it mean to be unusual? There's a lot in that word, that one word. That's what you should be trying to talk about here. All right? Draw some nice pictures for yourself. They've got them here, on paper. Draw them yourself. Try to explain it. The one other thing that you can try to do when you're doing this for yourself is pretend, you're not doing this for you. Pretend you're doing each section for, another student who missed class. So like, you got a friend in class and they missed it and they're like, what did we do? Well, of course you could just tell them like, we did these sections, go watch the video of, come on. Or you could think to yourself like, what if I really wanted to go above and beyond for this friend? I would write out the terms and things we used. I would put them, I would try to explain them myself because they can just read it from the book. What you would add is your own explanation, your own example that you really felt clicked. That's what you should be doing for yourself here. Pretend you don't know, you're a friend who doesn't know what's going on here. Explain it to yourself. Explain it to them, right? In your own words, making those connections, trying to put everything together. That's what you want to be doing. Of course, you run into something where you're like, I don't have a single idea. That's when you can go back to your sources, to me, tutoring, all those things to help fill that gap. But, that's the way one way you can attack this. You'll each have your own way of studying though, so, do what works for you. But if you're lost on how to kind of grapple with some of this stuff, especially because there's so many words you don't know, this is one way you can try to do this.